all. If you have one channel, it's like one utility channel you find all over Europe. Utility channel means everything is going through that. So if you have one transport system which is carrying the entire wastewater, be it septic tank, be it grey water, everything, it goes in one channel and it's never going to mix up with the stormwater drain. So even if after this, if you have not designed stormwater properly, there will be some flooding, it will go. In the media, which is soil, rock, weathered rock, semi-weathered rock, combination of that, arrange it in a way which suits to our design needs. So much organic load, so much hydraulic load, based on that, what should be the design of the media. So that constitutes the core of the technology. Then there are green plants, which is again, we have to look at how to maximize the biomass productivity. You have to select plants which give you more and more biomass. The reason being that more and more biomass, when you harvest, all the inorganic pollution, absorbed on the bed, that comes out. Therefore, it is a perpetual mechanism. There is no accumulation. And you will also find in Delhi, if you have seen Jamuna, you will find huge amount of froth. What is that froth? Is all this foam, which escapes our conventional treatment system. Because conventional treatment is designed to attack the carbon, nothing else. If it is a small treatment plant, you have activated carbon, sand filter, and all that. Large treatment plant, you cannot have activated carbon filtration happening. Worst case, you will have a sand filter and release. Next. So this is how the evolution has happened. That we started initially. Bombay also has this waste stabilization ponds, oxidation ditch. That's how we started learning how to do treatment. Then it has evolved, and finally we realized that the aqueous phase or liquid is not the right medium for all these kind of reactions, because it's a purely homogeneous medium and it really doesn't support life. You have to force with energy, nutrition to support life, and in the process we generate sludge. So if you want to avoid all this, we can move to soil instead of aqueous reaction. So then you have more future, you have to understand the soil engineering more and more and try to even attack the micropollutants. Today, which are not even considering, beyond BOD, COD, we don't consider anything as toxic. Next. Yes, this is the sequence. You should toxicity level, how it is increasing. Next. Conventional system, we stop at COD. So next, please skip. Since you know the operation maintenance, there is no such moving parts, so how simple it is. Technical, I will skip. I'm trying to just simply focus on 1 or 2 points. BOD means simple organics. This is how we should teach in the classroom students. We don't teach like that. COD means simple plus complex organics. Simple organics, if it is glucose, it's not a pollution. But they are acquiring so much of energy. The mosquitoes are entering our mouth. When we entered to see the conventional plant, they awarded me the next to set it next to it. So I said, you simply stop the aerator. When they stop the aerator, mosquito immediately. So these are directly connected. So we cannot locate it within because the air is highly polluted. And of course, if GHG or carbon footprint is not going to be, if it is still academic exercise for us now, tomorrow it will become a norm. NGT and us, we will create that awareness that we cannot simply dump and create a technology which is creating sludge and you dump elsewhere. That's not treatment. Next. In our our experience, 20 years, naval colony, they have 20 years plant. And I don't go to that plant, I handed over, they're running it. Now, can you show me a conventional plant, left it like that? There's so much of electromechanical, 40 to 50% of the cost goes into electromechanical components. Because we have a limiting media which may get clogged. And we also realize that if you look at the design of the wet well, when it comes to wet well, before that, if you can have a primary screen, then your wet well pumps will never face too much of wear and tear. Today we have improvised, this is happening in Germany. They have this, where they can drum screens. They can eliminate up to 2 mm, 3 mm. So that, but those are very expensive. So what we did, we got a reverse engineering done and we are fabricating so that automatically it will clear all the screen. I mean grids, everything, floating, grids, everything in one drum screen. And it has only 0.5 horsepower motor which is rotating within a drum.
Right.
And then automatically it is ejecting. You don't have to do the cleaning. Therefore, although it is common to all plants, these are the innovations we have done. Then what happens? Then there is a settling chamber. After settling chamber, we are directly pumping into the bioreactor. Now, what I realized that very fine solids, when they find the soil medium change, there is a natural tendency for the flocks to agglomerate and settle. So we are finding that over a period of maybe 1 or 2 months, we need to, maybe 6 months, we need to scrap it, which we might be doing here. I realize that even people don't want to do that. As a result, there will be some flooding. So we are working on a technology where even that is not going to happen. And we are going to give, this irrigation sprinklers. Irrigation sprinklers are very fine. So why we are providing sprinklers? Because you can do equal distribution throughout the reactor. Like the one which we have set up there, you find that perforated pipes are there, it is ejecting. At some point of time it gets clogged, then you have to manually clean it. So we want to make it totally hands-free. This is how I narrated how it, you look at the wet well, for that there is a screening process. Then there is the settling, and then one more is coming before the bioreactor one is the fine filtration system. Then at some point you want to make it completely automatic. You can operate the plant sitting here with IoT device. When to start, when to stop, increase the flow rate. You can do everything if you really want. After having this kind of setup, you can go for complete automation. This is how the media is arranged. You already have seen this plant. From the under drain to large particle to small soil, fine soil. Any question at this stage or move forward? So basically what happens, question comes, why the media we are not changing? Because you will find similar technologies, wetland, or phytorate, after some time it gets clogged. But our plant is running for 20 years. So I am trying to explain what exactly happens on the media particle around it. Media has a very high surface area and it has interconnected pores inside this because of the natural weathering of rock. These interconnected networks have been created. Inside that, there is good opportunity for the organism to colonize it. Geologically, it has happened on its own. We have not introduced. Because of that housing, so all the organism organic which is adsorbed, it is reacting inside those media particles. And because the colonies are growing, there is no plugging. Continuously it is being harvested. There is soil microorganisms, macroorganisms, and that's how you'll find a perennial device without